Hello there. It has been a while since you've heard from me in an intro. I've had a couple of episodes of interviews, and for some reason I just didn't do any kind of introductory blather and links for the period, but now I'm going to. Coming up later is an interview with Matt Butcher from Fermyon, where we talk about their cloud-native, cloud-hosted WebAssembly platform, and it was quite a good, insightful interview. But first, let's just run through a few links that have captured my attention, not in the past week, not in the past 2 weeks, in the past month. That's how long it has been. I do apologize. So first up, something on the New York Times from Brian X. Chen, a little roundup of privacy and security settings you should look at that you might not know about on your platform of choice. And the one that got my attention, which merits inclusion in the first place, was a recent addition to Android. I don't know what version exactly, but where you can change location data to be approximate location data. So there are certain applications that really do need your precise location, but a lot that don't. For example, weather. Weather apps have this tendency to be this privacy pariah, shall we say, and there's a way you can get, weather that is, to be fair, perfectly accurate for your use case without knowing your exact location. So that was one that I thought jumped out as me as something I wanted to mention and take a look and see if there's anything else that grabs your attention. Next, an article from Zach Leatherman, who I do believe I'll double check this, is the creator or one of the creators of Eleventy, a static site generator, looking at which generator builds Markdown the fastest. So turning Markdown into HTML. It's quite a short post. The benchmarks are by far the most interesting of what we really, really want. And the lower the speed, the better. So Hugo, by far the fastest. And he did this testing on 250, 500, 1,000, 2,000, 4,000 pages. Hugo wins in every case by quite a significant amount, actually. And one of the slowest is Gatsby, which doesn't surprise me. And Eleventy also does quite favorably, actually, just behind Hugo. If you look at the graph, it's quite interesting because Eleventy and Hugo are basically straight lines the whole time, and the others really scale up quite quickly. So, Remix and Next.js, and then one here that has a line that goes so high I'm not even sure what it refers to, actually. Goes up so high it goes off the page. Gatsby isn't so bad. Astro is one I'd not heard of. So, but I think Eleventy is JavaScript, which is interesting that it is so fast. I guess they're just simple, I suppose, is what is the takeaway here. But he talks about what he did with each of the tests, how he created the tests, and then did a little bit of polling and a few other things to get people's opinions on whether the tests were reasonable and what they thought of the results. But here you go. Here's another one. NPM install benchmarks, which is not so important moving forward on your static site generators, but let's have a look. So Gatsby also quite high. Obviously, Hugo is not JavaScript based, so that isn't so relevant there. It's Go based, so I guess it wins there as well. In that its NPM install time is very low. But it's worth bearing in mind a lot of this. And I can see since I first read this, there's been a lot of caveats and changes to the post ever since. So it's worth coming back and having a look. Actually, I think I need to have a reread now and check out some of these. I think that's some fuel for my hands-on videos, actually, to go back and look at some of these. I will be migrating my website very soon. More of that to be announced. And I think I will take a lot of this on board and figure out which I will use for my website. Very related, this is actually an episode of the Changelog. I don't think it's the most recent episode, but it's in there somewhere from about a month ago, building tiny multi-platform apps with Tauri and WebTech. I have done a video on Tauri. I actually had a request from one of my subscribers. If you haven't not a subscriber to my YouTube channel, then jump in straight away to do more Tauri content, actually. And I think it's probably time because from what I heard in the interview, A lot has changed, actually, and I think there's a lot more to look into the project. What is it? It's kind of an electron replacement. So this a tool that lets you use web frameworks to create cross-platform in very thick quote marks applications, but it has a Rust backend instead of the JavaScript backend. And so by doing this, it optimizes application size and performance quite a lot. And it's grown rapidly in popularity. I think when I first posted the video, it was quite new, and now it's a lot more popular. And I found it interesting because Daniel Thompson, who they interview, covering their recent 1.0 release, talks a lot about the community and the way he and the project thinks about things as well, which I also found very insightful, actually. I think that was more interesting than the actual technical stuff. He was a very interesting person and a very interesting interviewer, and it was great to hear how the project runs itself. So I'm sure you've heard of Changelog. If you don't know it, you go and have a listen to that episode anyway. Maybe reacquaint yourself with the podcast straight after this one, of course. Getting a little bit off tech quite quickly, I have definitely a lot of random posts to talk about now. This is one from IEEE Spectrum from Vaclav Smil. This is a bit of an odd one. I have been a vegetarian for some time, mostly because I don't actually like meat. But when you don't eat meat, I have noticed increasingly so that this availability of fake meat is very, very prevalent now. When I first got to Germany, you would find one or two things in a few supermarkets. And now everywhere I go, there are so many like meat substitutes. So it's very easy to think that meat eating must be going down. But this is not strictly true, according to this post, and it was refreshing reading. So the article title is "The Richer They Get, the More Meat They Eat." This is definitely something we always kind of knew. Ignore the hype that the world is about to turn vegan. And this digs into some statistics that kind of are masked by the hype to realize that actually what we think is happening is not strictly true. And so since 1970, there has been a 55% increase in worldwide average per capita meat consumption. And in some countries, it has gone up significantly. And this, I think, relates to this, the richer they get. So Pakistan, it has doubled. Turkey and the Philippines, it's more than doubled. Tripled in Egypt. Brazil has tripled. And in China, it has gone nearly sevenfold. Meat consumption has changed little in countries that are already eating a lot of meat. So this includes Canada, Italy, and the United Kingdom. And there's a graph here that summarizes these. And has declined a little in Denmark, France, and Germany, which reflects some of what I said. They're not actually on the chart, unfortunately, so I can't look at those. I'd be interested to see how that correlates to what I have seen about these kind of replacement ersatz, as you would say in Germany, meat things. And the somewhat slightly depressing, ignoring the environmental impacts of eating meat, of course, and the positive impacts, if that's a word, of not eating meat. The closing paragraph is one that I found somewhat sobering as a vegetarian, and one who often claims that it's also healthier, even though that's not why I don't eat meat. Even in those rich countries in which the consumption of meat has reached new heights, such as Australia, Brazil, Canada, and the United States, has led to no demonstrable ill effects on health. Spain is the best example. Since 1975, its average meat supply has more than doubled, but declined in deaths from cardiovascular disease. And that is a little sobering. I don't know. It's hard to know how to really, know how to absorb this, to be perfectly honest with you. I don't know. It's not really going to change my opinion on anything. There's lots of other reasons to not eat meat. But, I think, despite what you may see, I guess maybe everyone's eating more of everything. Maybe that's the summary. I don't know. Hard to say. I'd love to hear your feedback. What do you think? ChristianSchiller.com. What do you think is behind the sort of duopoly of an increase in meat consumption, apparently coupled with an increase in non-meat consumption? Is it just everyone's eating more? I don't know. Hard to say. Okay. Here's one that gets a little weird. This was from Narratively by Megan Gunn. Meet the obsessive role players who live inside the world of Grand Theft Auto. I think some time ago I covered this sort of reassessing of Second Life as being this kind of one of these first of these very immersive environments, but there's other things available. And one of these is Grand Theft Auto, although not quite. It's actually a forked version of Grand Theft Auto. Back in 2016, a small niche group of gamer programmers created this new world by altering the code of GTA 5 to create a large-scale multiplayer system dedicated to role-playing called No Pixel. And it's a GTA server, and it cuts out a lot of the things you'd expect from GTA 5. It doesn't have ultra-power weapons. It doesn't have explosives or military-grade snipers. There are no real goals anymore. And a lot of the kind of the sordidness of GTA, shall we say, has actually been somewhat turned on its head. And a lot of people actually role-play those characters who are probably much maligned in the original games and their lives. So it's quite fascinating. And the article opens up with a description of a funeral from a policeman shooting an unarmed civilian, and then the funeral of this civilian and how people role played it out. It's actually really fascinating, and there's entire Twitch channels and other streaming that covers people watching this almost like a soap opera. And I can actually find that appealing in itself. I think the problem I find with a lot of these is the time sink it would involve for me to fall into this world. And I'm not sure if the speed that it would roll out would be something I can cope with, like the slow speed. But coupling games with twisting of games and modding of games with streaming is definitely ticks all the boxes for me. So go in and read more and be quite fascinated by this world, and then find out how you can join in and be a GTA maligned sex worker and roleplay out what that might be in this slightly skewed world of GTA. Fascinating stuff. On the subject of odd worlds, this is going back a little bit. This is from Amanda Yo on Mashable. 10 burning questions we have after the Umbrella Academy Season 3 finale. I loved Umbrella Academy. Season 3 of Umbrella Academy was out. I was much more excited about watching it than Stranger Things, which I haven't actually watched yet, the new season. I found this quite an odd... I won't really go into too much detail because it's probably a spoiler and it's a little meta. But a lot of questions here about the show. And it's interesting because I've been reading some production notes of Battlestar Galactica recently. They're both seasons, but largely 90% of the book focuses on the recent 2000s season and how TV seasons generally get created. And invariably, it seems to be far more spontaneously than you might think. So I feel like sometimes that people who watch TV shows might wonder, like, why did that happen? Or why did that happen? And why was that loose end not resolved? And things like that. And I don't always think there's an agenda for it. I think it's just how TV shows get made. And things just get kind of forgotten about along the way or don't get resolved, and there's not always a reason. But there might be. I don't know. So these don't actually necessarily answer all of my questions, that's for sure. And I think especially with a show like Umbrella Academy, there's a lot of this suspending belief, suspension of disbelief. You just have to put up with it. So one of the questions is, why do these two characters know each other's languages? And you just kind of say, well, it's the Umbrella Academy. You talk about time travel and weird superpowered people. Just deal with it. And I'm a big fan of speculative fiction, which does this a lot. You're in this world. These things are true. That's just what it is. Don't ask those questions. The questions we want to ask are different questions. And I wonder if that's what Umbrella Academy actually does quite a lot. Although there were definitely some of these I agreed with. So go along, watch the season, read these, and give me your thoughts. What questions do you have? I kind of get the impression that in my mind, I wasn't actually expecting it to be a season 4. So I get the feeling a lot of these will be answered in season 4, or will they be? But I actually, for some reason, thought this would be the last season. I don't know why. I wasn't sure how popular the show was, to be honest with you. I don't know many people who watch it apart from me. Maybe it's more popular in other countries. So, yeah. We will see. Hopefully they'll be answered. They probably won't be. And it's the Umbrella Academy, and that's okay. And finally, someone talked to me about this recently. This is nothing new. And I'm just picking up a post here, an anecdote from Sean Callahan, what might Amazon's 6-page narrative structure look like? This was something that someone told me about how Jeff Bezos banned PowerPoint presentations in meetings and says you have to write a 6-page narrative memo about what the meeting is going to be, what it should accomplish, this kind of thing. And says it finds it much more encouraging about getting progress and productivity in meetings, basically. And so I was reading around what this might mean. And I didn't end up finding as much detail as I would have liked about how I could sort of turn this into something useful for me. But maybe if you want to figure out ways to get your meetings more on point and more productive, it might be worth looking into or thinking about it for other things. I think that's what I was wanting to take from this. How could I use this to pitch stories, pitch books, pitch games, pitch all sorts of things? How could I use this to script videos, etc., etc.? How could I take this similar idea? So have a look at the link I sent you. See what you think you could apply it with. I feel like sometimes these are always interesting lessons to learn, to figure out how you could use them and apply them to other contexts. And that's actually something I always like reading about and seeing how that could work. All right, after that rather random grab bag of links, let's get down to the interview for this episode. This is with Matt Butcher of Fermyon, talking about their WebAssembly platform for running microservices and web apps. And we discovered a lot of common connections as well, going back into our past. Enjoy. This is interesting. It's WebAssembly. I'm actually working on a video right now as an introduction to WebAssembly and have experimented in a couple of different places. But I get a suspicion Fermyon fits into this sort of WebAssembly platform hosting space that a few companies are emerging into as something as an alternative to other options. So how about you fill in the gaps of my assumptions there and tell me a little bit about yourself and Fermyon?
Sure. Yeah, and thanks for having me. Probably a short autobiography of the cloud is a good way for me to kind of start into what we're doing at Fermyon. I got really interested in the cloud back a little over a decade ago when I joined HP Cloud. I joined originally to run one of their CMS systems. I was a big Drupal developer.
So was I,
back then. Drupal, by the way, one of the most amazing communities I've ever been part of. Yeah. And I've been doing open source for I've been doing open source for a really long time, and I think I learned more about open source from the Drupal community than any other. And I'll circle back to that as we talk about how we're doing it now. But I've been doing Drupal for a while, and I joined HP Cloud, and I'm doing content about virtual machines and about public cloud. And as I'm starting to work on this content, I'm going, this stuff is amazing. I mean, this is such a game changer for me. For so long, I looked at, the operating system and the hardware as having basically a one-to-one relationship. You can only run one at a time on a piece of hardware. And this was upending that set of assumptions. And more than that, suddenly I could run my operating system on somebody else's hardware that I didn't have to manage or know really anything about other than whether it was fitting my needs. So I kind of pivoted in my career from doing content management into doing cloud. I started working on a number of OpenStack related projects and was just absolutely in love with the technology. A few years later, HP Cloud didn't quite make the cut for the top list of public clouds, and I ended up moving over to a small startup in Boulder, still doing cloud stuff. And, they got acquired by Google and things. And I ended up working at Deis. And all three of them were kind of big in the container space. And so, I started shifting my thinking from, hey, I want to work on virtual machines in the cloud to, this container thing. This is the new thing. This is what I want to do. And so, at Deis, I was working on their CMS system, which was essentially a Heroku style platform as a service, but where we were using containers rather than, build packs plus virtual machines as the runtime. And we were looking at orchestration. And orchestration was a big problem. How do we take these containers and distribute them out on our production cluster? And we were playing with Fleet from CoreOS, which we really liked. And then, all of a sudden Mesos was an option. And then along comes this one where nobody knew how to pronounce it. We're all like Kuber something or
Most
other.
people get it right. There's still one or two quite high profile people who pronounce it a bit like a variety of wine, but yes.
Yep. I'm pretty sure I started out calling it Kubernetes or something like that. Even with a little bit of background in Greek, I wasn't quite sure. But we replatformed in 2014-15 from Fleet onto Kubernetes and experienced a bunch of early problems there, right? How do we install things? So we started building tools, and I started a project called Helm there, and we started a couple of other related projects.
Helm is in the Helm that people use now. Okay, all right, okay.
Oh yeah, okay. Yeah. Helm, the package manager for Kubernetes. That was originally called. So the quick story for Helm is we're at Deis, we're pivoting to Kubernetes. And Gabe and Bo, the CTO and CEO, said to me, okay, well, you're kind of one of the reasons we're doing this. So why don't you explain to the company what Kubernetes is, and then we're going to do a hackathon and we'll work on some projects. And I'm like, oh, I guess. Okay. And so I said, all right, so this is, and remember, Engine Yard and Deis are part of the same company. Yep. So I'm talking to a bunch of Rails developers, a bunch of, Go developers and stuff like that. And they said, oh, by the way, this meeting is going to include marketing and it's going to include, all the biz dev and stuff like that. And I'm going, I am supposed to explain Kubernetes, which I only recently learned how to pronounce, to a bunch of non-technical people in addition. And they're like, yeah, you can do it. No problem. By the way, we gave you this slot after lunchtime. And I'm going, nobody's going to be awake at the slot after lunchtime. So I took my kids' stuffed animals and posed them around the house and took a couple pictures and put together a slide deck called the Illustrated Children's Guide to Kubernetes and pitched that to the whole company after lunch, sitting in an old chair in the front of a screen in an old hotel in Boulder, and kind of used my PowerPoint to scroll through the screen and read it kids story style. And we ended up creating the Children's Illustrated Guide out of that. We could do something with this. And then that afternoon, we kickstarted a hackathon, and my team decided, hey, let's try building a package manager for Kubernetes. So in one day, we had kind of these two bigger Kubernetes-y things happen in one room. The prize at stake for winning the hackathon was a $75 gift card to Amazon that we split three ways. That's right there. The big payoff at the end of the open source rainbow was a $75 gift card.
That's more than some. So there's quite a lot there. In fact, Helm is a tool I really like. I still have an Engine Yard t-shirt from some event in Paris, I think, from several years ago, when I was working for a company that also pitched everything into Mesos. So actually I really like that t-shirt. The red one with like a...
that one. Oh, yeah. Yeah. I know what you're talking about. That one. A few of us, I actually don't have any left. A few of us on the team, though, still have Engine Yard t-shirts. And one guy's got the black one with the Engine Yard written out in kind of a funny heavy metal font. Yeah. That was one of my favorites, too. But
well, fast forwarding a little bit, let's get to Fermyon. And I would like to firstly let you describe what it is, and then I'd like to dig into a few details of what that description is probably going to throw up. So describe what it is first. And then we'll
so Fermyon, the company, is a group of us who came from, many of us from Deis through Microsoft, and we were starting to work on WebAssembly as a kind of third wave of cloud compute. And, again, harkening back to this container story, right? We were learning a lot about containers, and we continued on at Microsoft and said, okay, so there's some lessons to be learned here, right? Some things we can't quite figure out how to do with containers. Containers are awesome in a wide variety of cases, but we were running into some cases where we just couldn't get what we wanted out of them. And so we started investigating different technologies that might be, the next kind of cloud compute. And we were kind of envisioning there'd be three kinds of cloud compute. There'd be virtual machines, containers, and X. What's X? And WebAssembly had, because of the way it's built, right? Because it's targeting a browser, it had a lot of the features we wanted, right? Ultra fast startup time because browser users are intolerant of waiting for anything to load. A really good security sandbox model because, again, you don't want to get rooted through your browser. And then, the de facto standard in browsers is, well, it's got to run on any architecture, any operating system. And the goal was to support all the programming languages. And and all of those were just like fitting perfectly with a lot of the goals that we had in mind. So we began building a technology to run WebAssembly in the cloud. And we tried by fits and starts a couple different ways of doing it inside of Kubernetes and stuff like that. Ultimately, we decided what we wanted to do was start a startup, really rethink the problem space, and then build a technology that we felt like was really getting the most out of this emerging technology. So our first big release was in March of last year, very end of March. The goal was, let's not release on April Fool's Day. So we released the day before April Fool's Day. Like true software engineers pushed it all the way up to the line.
I'd also like to point out that you're based in America. So for a lot of the world, it was already April 1st.
True. Yeah. So yeah, we got it out the very last day of March. And this was the first expression of how we thought a developer would approach building WebAssembly binaries that would execute in the cloud. So it's very much oriented around the developer. Our core kind of user story was then and still continues to be, as a developer, I should be able to go from a blinking cursor to a running application in 2 minutes or less. We had heard people say, well, the WebAssembly toolchain is hard to use. And we went, okay, well, that's a problem we'd love to dive into and solve. And we had heard people say, some of these other building a virtual machine is a long and cumbersome process. And we didn't want to go that route, right? And so we really kind of focused on that as our first entry into the space. And then the next big release we did just a month and a half ago in June was to release a platform that you could install on AWS or DigitalOcean or Google Cloud or Azure that as an operator, right, you'd have a place where you could direct your developers to deploy these applications and have them run in production. Both of these are still fairly early technologies, right? Neither of them have reached 1.0, but we're just thrilled with the fact that our initial assumptions and experimentation that we did so long ago are now being borne out in a very fruitful way. In a sense, it's good to find yourself more and more convinced as you go that you've landed on the right technology to solve the set of problems you set out to solve. And I feel like that's where we are right now.
I would just like to very, very quickly, because I think it's one of those technologies that is mentioned a lot without people always fully understanding it. And having just recently put together this video myself, could we very, very quickly, like 30 seconds, what is WebAssembly? What does it mean?
I mean, we all recite this. It's a stack-based virtual machine, kind of thing. But really, WebAssembly is two things. It's a definition of a binary format that you can compile applications to, and a definition of the runtime that would be able to execute those. So really, probably the easiest analogy for us is to say, think Java virtual machine or .NET CLR, but built with a different set of design constraints that keep it. So when you're talking about like the host and the guest, right? So the host is the thing that's executing something on the user's behalf, and the guest is the thing the user wants to run. In most virtual machines, the assumption is the host and guest are both operating with high degrees of trust in each other, right? When I run a Java binary, in the vast majority of configurations, the assumption is, well, yeah, I should be able to access the file system. Yeah, I should be able to access the network with no restraints because I'm just running my code, right, on my machine. And WebAssembly went with a different security profile, which was the host should be able to execute guest code in a risk-free way. Right. So with a high level of security, the guest should not be able to access surprising locations on the file system or environment variables or network connections unless the host says, yes, these are things you can access. And so, at the end of the day, you can think of it as sort of like a high security Java virtual machine or high security CLR for .NET.
Yep. But also far more performant. I think it's bytecode.
Yeah.
So JVM adds a lot of overhead on top. Yeah.
And right. You're exactly right. And part of that is because it was designed to be very lean. Again, browser profile, got to start fast, got to run fast. And because, and we all have to acknowledge this, right? We all stand on the shoulders of giants. The JVM and the CLR have proven to be the grounds for a lot of research over decades, right? And where they're still still started in the late 90s, and there's nothing we can do to change that fact, right? The lessons we've learned over the last 30 years can now be applied freshly in this new environment. So speed, when it was talk about, we waited years and years for a JIT in Java, and JITs and AOT compilers are just part of all the WebAssembly runtimes now, because we know how they work and we know how to write them, and there's like decades of best practices in place. So for that reason, you're starting off with a much higher performing, much more svelte, much more secure and well understood virtual machine than when that was groundbreaking in the 90s.
I would like to dig into one other part of what you said, and that was when you say it's WebAssembly in the cloud, what's running where? Because traditionally with WebAssembly, it's running in the browser. So what's running with Fermyon? What's running in the browser?
Yeah, and we should starting with the browser is the right place, and we'll see the little dotted line form as we go. Right. WebAssembly's design for the browser was not necessarily to replace JavaScript. I know every once in a while it gets framed out as it was intended to be the JavaScript killer, and it wasn't. Well, no, it wasn't really intended to be the JavaScript killer, right? It was intended to provide a way to augment the JavaScript runtime in a browser and support other languages. But the cool thing about WebAssembly, and this is why I don't like talking about it that way, is that WebAssembly was built to be connected to JavaScript. Right, from its get-go, the Luke Wagner, the other developers of the early WebAssembly spec were going, okay, how do we make it so that it's easy to exchange data between JavaScript running in the browser and something else? Might be Rust, might be C, might be Python or Ruby, and so it was built to function in a way like languages like Lua, right, where the assumption is they'll run in some kind of sandbox, and a developer will do some work to connect the sandbox to the outside environment. And it's largely successful at that in the browser. That was the thing that we really liked when we were starting to work on the cloud side, because to us, we were going, okay, so we could pop the whole runtime out of the browser, plop it down in the cloud, and replumb all of those things so that instead of talking to a JavaScript runtime, it's talking to the system. And we discovered, and this is 2018, late 2018, we discovered that there were already a group of people, and it happened to be many of the core WebAssembly developers who were working on the same thing. And they were working on a project called WASI, the WebAssembly System Interface. And this was essentially the outside the browser bindings, right? So the inside the browser ones are designed to connect to JavaScript. These were designed to connect securely to the system resources. So the early versions of WASI had some very uninteresting but highly important features like, well, we can access the system clock, right? And tell what time it is. We can access the random number generator. And it was all built on a capabilities model where you as the host administrator could say, well, it's allowed to do this, it's not allowed to do that. They added file system and environment variables, and you can say, hey, so the guest module needs a file system that it believes is mounted at Etsy. Unlike necessarily Docker's way of doing this by creating a full external isolated file system and then mounting all of that together, the WASI way of doing this was to say, okay, we'll basically virtualize the file system. And the standard WASI libraries will be able to connect to a real file system, but you could also connect it to in-memory storage that looks like a file system to the guest module, or object storage somewhere or whatever. And you can layer on these controls, like it can read this directory, it can read and write in this directory, can't see any of this stuff at all. And so because of WASI and the way this evolved, it became not only possible, but actually rather compelling for us to say, okay, well, we can build a cloud runtime on top of this that will execute all of the functionality on the cloud. So there's no, in our way of doing things, right, there's no necessary browser component at all in this, right? It's all executing in a runtime on the cloud. And then the kinds of problems that we then started tackling was, all right, well, how do you write a web service using this, right? The server side of a web, how do you write a microservice doing this? And we looked around and said, okay, well, what do developers tell us they'd like to do? And, functions as a service and serverless, both of these are terms that we're familiar with, describing a way of developing applications that developers seem to really, really like. And we actually heard that all the time at Microsoft. Oh, I like writing in a functions as a service style. I like Lambda. But we don't like the way that it runs, right? We want it to run differently. We want to be able to write these kinds of applications. We want to be able to run it locally. We want to be able to debug it this way. We want it to feel more like our existing tool chain and less like we're writing a program that we're going to have to upload somewhere else and see if it works. And so we took that to heart and said, all right, so we want to write web applications. We want to write microservices. And developers tell us that this whole event-based function as a service kind of model feels really natural. It gets them straight to the writing the code they care about without all the boilerplate. And so we built a system based on sort of that set of premises. And so if you download Spin today, right, the kind of applications that you should have no difficulty writing are things like, I wrote an HTTP, request response handler, or I wrote code that'll sit on a Redis queue and listen for new events coming in over a channel, because those are the kinds of things that fit into this microservice functions as service kind of paradigm. Yeah.
I'd like to go down that spin path in a second, but just one other question on the platform itself. My own experience of playing with WebAssembly was that despite the promise, it's, just write and compile to the browser. It actually, you have to add some stuff to your code for that to happen. With yours, is it the same? Is it basically the same process, or do you have some extra magic that can take any Go application that is applicable and make it run in WASM? Or do you still have to go through the same underpinnings in your application to add the libraries and the bindings and that kind of thing?
So the question is slightly nuanced, in that. So the way WASI works is that it just overrides. So when you compile a Go application that opens and closes a file, and you compile it to WebAssembly with WASI, then essentially the WebAssembly interpreter, at the point at which you start doing I/O calls into the system, it's just going into the WASI layer instead of going into the actual, operating system's file system layer. So lots and lots of applications can be written without modifying the code, right? So, and the same goes for many of the core operating system things. Little. Now, the reason the answer is nuanced, though, is because WebAssembly is still, a newish language, right? It's a little over 5 years old now. Actually, it's a little over 7. It's a couple days over 7 years old now. To put this in perspective, right? Ruby on Rails came out sometime after Ruby had hit the 10-year milestone, right? So we are talking about a younger technology. There are a few big things that are not yet in WebAssembly. Probably the most salient would be threading. Which means, if you try and compile a library into WebAssembly and that library uses multi-threading, then at this point, the compiler will error out and say, you can't do this. Depending on your language, it'll give you a different variety of error message that says, you can't do this. So there are a few things like that. And it's not because they're entirely missing. There's plenty of work going on for porting these over. And I actually don't doubt that it'll be end of year before we see really implementations of threading coming out based on the W3's work on the WASM threading specification. But as a startup, we took the gamble, right? Where you look at it and say, okay, well, there are things missing. We know those things will get there. If we jump in now and start building the technology, then we can fit those in as they come along. But if we wait too much longer, then someone else will get the jump on us. And so, we accepted that. And largely what we've discovered is because, again, that functions as a service model tends not to be heavy on multi-threaded application development, right? The tendency seems to be more to use that kind of CSP model where each function does one thing in thread, and then multiple ones might be handling more complicated processes. So we've been able to really build the kinds of applications we want to build without that. But that's not going to be true for everybody, right? So we're really excited about the fact that threading will be dropping into most of the WebAssembly interpreters within the next, 6 to 8. Again, I'm an optimist. We started a startup. You got to be optimistic to start a startup, but I think 6 to 8 months now, and we'll see threading drop in. There are a couple other facilities like that too that will continue to develop and get dropped in. Some that will help with mathematical computing. Some that will just help with memory management for complex languages and stuff like that.
Just realized I've been looking at the wrong website, which probably answers some of my questions. You have fermyon.dev and fermyon.com. And I've been on .dev the whole time, which doesn't tell you a whole great deal. So I was kind of like, what am I missing? Now I've just come to your actual website and I've now discovered. So you mentioned Spin already. It seems like you have a couple of different components. I can see the platform, Spin, and Bartholomew. What are all these things in?
So we started with content management systems, and now we're coming full circle here. We wanted to prove that WebAssembly was not a toy technology, right? It was several. When we started this project, if you went around and looked for examples of WebAssembly code, you got the Fibonacci, calculating the Fibonacci series, writing hello world, doing a simple for loop. And we were going, well, we're putting a flag in the ground saying WebAssembly is ready to write production grade applications. We better be able to write a production grade application. So we started Fermyon on November 1st. Yeah. The first project we started was called Project One. We're not terribly imaginative when it comes to project names. And the goal was to build our own website, fermyon.com, completely on top of our own WebAssembly technology. A modest first goal. And so, we wrote Bartholomew, which I'd actually kind of started a little bit before that, but we together worked on Bartholomew, which is a content management system that can compile into WebAssembly, that can execute inside of Spin, and that has I want to call it fully featured because it has all the features I want, right? It has a templating language to write out HTML templates. It uses handlebars. It has an embedded scripting language, a language called Rye that's basically like a sort of like Rust Lite, so that you can write, the code to index through your blog posts and sort them by date, and then spit out an ordered list. And it has a file server, all the basic things you'd want for a CMS. Again, coming back from the Drupal days, I'm going, okay, well, I know exactly what I want. And we built Bartholomew as two things, right? We wanted it to run our own website. We wanted to eat our own dog food / drink our own champagne, however you want to fill that one out. And we wanted to prove to everybody, very seriously, we can build some pretty sophisticated applications out of WebAssembly right now and run them in the architecture that we're telling you is the next wave of cloud computing. And we've been actually really happy with it. Bartholomew pulls incredibly good numbers on the Google page speed test. So we targeted, I think, 90% out of 100 originally. We got up to 99% out of 100. And we're going, wow, it's because WebAssembly is so fast. And because we're essentially running, binaries that are highly tooled to streaming data right back out over the network, we managed to pull off some really great performance numbers and consequently, build a really SEO-friendly CMS. So while we weren't originally ever thinking of making it a product, and we really aren't thinking about making it a product, we decided that it was general purpose enough that we could kind of put it out there and let people experiment with it. We were surprised to see, and are surprised to see, that one of the first things people enjoy doing with Spin is setting up Bartholomew and, converting their blog over to it, or standing up a new blog using Bartholomew, just because it's an easy thing to do. And we all want our blogs to be running some cool tech and to experiment. That's been a fun one.
Yeah, I need to change mine. It's still running Jekyll. And I've kind of pushed Jekyll to its limits, but unpicking it is just too much work.
That's the never-ending cycle of blogs. We jump on the new and shiny. It gets hard to manage. We jump on the next new and shiny. Yeah, but
it's been running Jekyll for some time, so not exactly new and shiny, but yeah. And so is Spin? I guess then that the platform is kind of a commercialized version of Spin, or is it?
So they're currently all our projects are open source. We are building toward a software as a service kind of offering, because I'll come to that in a second. So Spin is really oriented toward the developer. So to create a new application, you download Spin, you type in, you want to do a new Rust application, Spin new Rust my project. You type it on the command line and it sets everything up. It gets all your WebAssembly compiling targets set up correctly. And you want to do the same with Go. It's, Spin new Go my project. And then you've got everything set up that way.
Okay.
And then, you're typing commands like spin build, and regardless of the language you picked, spin build will figure out how to run the compiler and compile everything to a binary, and spin up will start a local web server, spin up a local web server, and you can test your application locally. So Spin is really oriented toward what we call the developer's inner loop, right? Where you're heads down in flow working on your code. Spin's the tool you use to do that. The Fermyon, the platform, is where you deploy things. So this is more the DevOps oriented tool where you fire up Terraform and install it on AWS, and then you type your application, you type spin deploy, and it pushes this out to Fermyon platform, and then you've got something running in your cloud tenancy. So that was really, we wanted to solve both the developer story, the inner loop, and the operation story, the outer loop, both in open source. Spin, the platform, uses Nomad and Bindle, and so Nomad's HashiCorp scheduler, and Bindle, which is a package management solution for WebAssembly, and Hippo, which is a dashboard for WebAssembly, and then uses the Spin runtime to execute things. So when you run Spin up and you run Spin deploy, they're running in the same underlying WebAssembly execution context, but in different places.
We're running a little close on time, but I have three more questions I'd like to ask. Just out of interest, WebAssembly's big selling point is its speed and efficiency. So using something like Spin, Fermyon, how much of an overhead am I adding to it?
Actually, it's a little more subtracting overhead at this point. One of the awesome things about long-running WebAssembly runtimes, and this is the same is true of JVM and CLR, right, is that we can pre-analyze the binary that we're executing and begin caching and AOT compiling and doing all kinds of pre-initializing, all kinds of neat tricks to speed things up. So, you'll hear WebAssembly is fast in the browser, but when we're talking about it on the server, we're not talking about tens of milliseconds. We're talking about sub 1 millisecond from request to the execution of the first instruction. So it's fast because we can pre-optimize.
Okay, cool. Next, I know of at least one other company doing something similar, but there's probably more than that. How do you consider yourselves different? What's your It's late on Friday afternoon. I can't think of any better words. Why are you different?
The elevator pitch. Well, I mean, really. So, and yes, there are a lot of companies entering the space. Wasm Day, which is part of KubeCon, pretty much has been doubling in size because there's so many new companies in so many related industries. For us, really, our thing is that we really are focusing on this third wave of cloud computing thing. We really want to build the right compute architecture to execute WebAssembly in the cloud. And to us, that's really, there are two responsibilities there, right? Responsibility number one, we've got to have cost-cutting, hyper-effective, super fast, secure, and reliable WebAssembly services that run in the cloud. And number two is we've got to build the right experience for developers to fall in love with this technology, right? We want to make it so easy and so pleasant that people are excited to write this code like they were when they wrote their first Docker container, like I was back in 1997 when I wrote my first Java program. And so those are kind of our two dual goals there. And what really sets us apart, I think, is our kind of laser focus on building an analog to VMs and containers, but one that will use WebAssembly as the base format.
And obviously everything is pretty new, but what's on the roadmap for the next 6 months?
We are working hard on a software as a service because what the next thing we want to do is make it super simple for a developer to say, hey, I built my first application. Let me push it somewhere. And then it can be publicly available and I can show my friends and family and I can run my blog and so that'll be the next thing we're working on. In addition, we've got all kinds of new features we're adding into Spin. Database support is finally coming along. Object storage is coming along. And so some of these things that are just like developer bread and butter will be rolled out so that we go from like early beta to something that's really kind of scratching all the itches we normally have when we write code.
Okay. Cool. Anything else you want to mention? I think you have a Discord community. I can see is probably the best place to kind of get in and find out more, I guess. Discord.
Yep, drop into Discord for sure. Join us on Discord. We're working on setting up some easy issues where people who want to dive in can get going. And of course, there's also, we publish regularly on the blog. So if you want to kind of catch up on the theory behind a lot of this, there's plenty there. And WebAssembly Day in Detroit at KubeCon, for those of you in North America who would like to travel to North America, that's a great opportunity to get connected, not just with Fermyon, but with all the different teams, Fastly, Profion, Adobe, all these other companies that are in here with us working on WebAssembly and the next wave of cloud computing.
And that was my interview with Matt Butcher of Fermyon. Updates from me. It's been a little while. There's a little bit to cover, actually. I'm probably going to drip it out as we go. I think the main one I want to cover is that I have already, I'm in the process of restructuring my videos a little bit. There's now going to be kind of taking the place of what was sort of hands-on and the Solo Adventurer is going to be my learning live streams, where I'm going to very much just do, I'm here streaming me learning something. Why not? I'm going to do it anyway. Why not stream it? And then I will take some of that, but also some of not of it, just my own kind of external research, into making much more edited videos for hands-on, which will be much more solving a problem, edited, slick, helping you get somewhere, and also with my game reviews with the Solo Adventure. It's going to kind of be the edited ones moving forward, and probably a lot more besides. I'm about to do a lot more video work, actually, in the next few months. So those are the main things for now. There's going to be a lot more announcements coming in the next couple of weeks, actually. But for now, I will leave it there. Head over to christianschiller.com to find links to YouTube and Twitch to see these various outputs that I'm working on. And you can also see that I have upgraded my video setup as well there. So take a look at that. It's still a bit in progress, but it's getting there. And moving forward, I think if you want to say hi, the next event I will be at IBC in Amsterdam, covering that for myself and also for office hours. So if you happen to be in Amsterdam or at IBC, come say hi. I'll be wandering around with a camera doing lots of interviews. So until then, and until next week, thank you very much for joining me, everybody. Take care. I hope you enjoyed the show. Find out more about me at chrischinchilla.com, where you can find show notes, sign up for my newsletter, and find all of my writing, games, work, and video links. There's also details on how to get in touch with me. And if you want to get even closer to what I do, join my Discord server for behind-the-scenes discussions and helping me produce my shows and work.